If for some reason you are a regular viewer of my channel, you have probably seen me use my homemade CNC to make guitars. I mean, many guitars so far. And I'm running into a couple of troubles. Mainly struggles with, I don't know. But what you have not seen is me getting into struggles with my size. I know, it's hard to admit, but I have to say it. My CNC is too small. I know, and I hear you, people often say, hey, it's not about the size, it's about stepper motor torque, it's about variable frequency drives, it's about a whole other things, but deep down inside, you know, it's about the size. This is the current work size area of my homemade CNC, 42 centimeters by 52 centimeters. For all of the Imperial folks, here's a potato for scale. And yes, a potato is a perfect item for scale. Everyone has it, literally. It's a potato, come on. Here's the table alone. It's huge, it's big. I kinda decided halfway while making this table, hey, I should maybe record it so I have more content. I know it's not a guitar build, but hey, people might want to see it. So here's a couple of snapshots of me making the table. This epic table will include drawers that are right there. I'm waiting for the drawer slides, for the legit version of the drawer slides. Power cabinet over there, and right there is over here. It's not a permanent solution, ignore the cable. Epic cabinetry. I mean, just look at it. It's something you would even want in your kitchen. 3D printed height adjustable legs for ultimate height adjustment. But as you can see, it's a proper table for a proper CNC, which I still haven't mentioned. I bought a RatRig Stronghold Pro. It has some decent spec. It's more DIY-ish, which is perfect for me because I want to kind of improve on some things and not improve in other things. So for me, it seemed like a perfect pick. Still, I kind of wanted to make it my own. So I'm going to throw in a couple of modifications, a bit more power under the axis so I can break more bits, because that's the fun part. But also I'm going to improve the space over here, because you can see no lighting, it's poor lighting, so we're gonna probably add a light over there. Maybe also paint the walls to white so refraction is gonna be a bit better. But for now, we're still waiting on the parts. But why wait for parts when we can just spawn them in on the table, because it's a video. I'm breaking a fourth wall. Which wall even is the fourth wall? I'm scared. Let's spawn this thing like this. Oh, wait, you're not the CNC parts. Lily, hi there. Hello, doggo. Hello, doggo. Awkward situation. You're probably napping, but oh, let's try it again. Maybe I get to throw it in the head. So let's do that. Now that's a lot of boxes, finally. We got the right order. We have a couple of long boxes, we have a couple of small boxes, and we have a medium-sized box. That's right, I ordered my own stepper motors. RatRig provides good enough motors, but I want more oomph because I'm totally not compensating for something, but we have electronics and stuff and things. The aluminum extrusions and stepper motor stuff. So, let's get to the unboxing experience. Yeah! And the unboxing's finally complete. When you unbox it, it looks kinda small, but ignore the pile over here. We're going to deal with that later. But for now, these are all the beams for the CNC, all the ball screws, all the rails, all the potatoes, stepper motors, and stepper motor holding plates, or whatever you would call them. I prefabricated these parts, these holders for the stepper motors, so that I could mount them in a weird way, which I will show you later. But for now, these are the plates I manufactured myself, because I wanted to lower the footprint of this printer because it's already kind of huge in this room. So we're gonna see later how these brackets might help me make the footprint of the printer in the room a bit smaller. So without further ado, let's get to some wacky stuff. If you take a look at these aluminum extrusions, you'll see a lot of things in common, like a T-slot, a threaded hole, and a huge hole for potential of absorbing vibrations. And that's why I'm filling up these huge holes with resin and sand. Why? Because aluminum likes to absorb vibrations, it likes to translate vibrations, but if I put another medium in here, that medium can absorb some of that vibration, also add mass to the whole CNC, which is good. And bad because inertia. Because if you move a heavy object, you need a lot of energy behind it to actually stop it. But vibrations be damned. So to start, we're going to plug these holes with this 3D printed plug, which inserts here rather nice and snug. Also 3D printed this fancy funnel to make the pouring of the resin sand much easier. So without further ado, let's hammer in some plugs and start making the machine even heavier. I know that filling in the empty space in the extrusion is kind of pointless, waste of material and money. To hell, science says that, hey, traveling through one medium to another wastes energy if they're not similar. As with anything, small scale is the way to test things out, and just for my sanity's sake, I thought, hey, I could test just these small two pieces just to get the concept down before I waste a lot of expensive resin and a lot of pretty nice sand. So I filled this one with sand, this one is not filled with sand, similar lengths, similar clamping distance from the edge, so it should sound the same, right? But already just with sand inside, a bell, a wall. Yeah, sounds the same as the wall. So already a first change in this project. I'm probably just going with the sand, because for me that's just enough dampening for what I need. So let's proceed onward. So I had some time lying around over here and over there while waiting for a couple of components and tools for the assembly of the CNC to make this place look all nice and pretty. Painted the walls, add some panels, also trued up the table because it was kind of bent at some places, so I trued that up. So there's nothing else left to do then. Assemble the CNC, starting off with the gantry, because if I start with the base of the CNC I won't have any room on the table to start the assembly of other parts, so let's start with the gantry. Let's go. So RatRigs manuals start with the assembly of the base of the machine, but I will skip that part and do it later. First off, I'm going to start with the gantry because it seems more logical. I still have the whole table empty, so I can have enough room to assemble this beast and then do the base of the machine. So I'm going to follow the instructions and maybe do some of my own stuff. I have a torque wrench just because I want to torque them to a specific torque. I'm going to glue them, it's not necessary, but it's a vibrating machine, so just in case. But anyways, let's start the assembly of the whole machine. So I ran into a slight issue with squareness. Using the little 1, 2, 3 block, I tested the squareness and I could feel a 0.2mm shim underneath it, so that meant something is out of whack. So I did a bit of poking around and found this unevenness in the paint coat. As you can see, there's slightly more paint in the corners. I know this might be nitpicky, but it's an easy fix, so I have no problem with it. Just do a little bit of sanding to get a nice flat reference surface. Another thing I noted is that these two surfaces aren't parallel to each other. This one shoots slightly inward, so this could be another reason why I have a fitment issue. But with a little bit of playing around of turning the profiles, got me pretty spot on the 90 degrees. But what I would recommend is that you sand these little triangles and then clamp something flat on the sides of the profile so you get a nice reference, so that you know that this is perfectly aligned with the bottom. Another quick suggestion that I have: use the extrusions as your base for the gantry. It's an unflat surface. Keep in mind it's gonna reference the things that you have under, so if this is not flat, this surely won't be either, so keep that in mind, but it's gonna keep your profiles nice and flat this way. Another thing, you can get easily clamps underneath it so you don't deform the C shape, so a pretty decent setup. And now that the gantry has been perfected, it's nice and square everywhere, it's time to add some linear rails. But you might be wondering why I'm wearing gloves. Well, these are full of oil, covered in oil, so we have to wipe it all off, and then we can finally add the rails to the gantry. Once they're on the gantry, I'm going to meticulously make sure they're parallel to the extrusion, and only then, we can start assembling the Z-axis already. And now that I have both linear rails attached, I'll dial them in perfectly to within 0.01 millimeters. They're super parallel, which is super nice if you don't want to jam. Now that this is figured out, it's time to add the ball screw, and then later on add the Z-axis. So it's time for more assembly.
And I can't turn back.
And now that it's time to actually mount the Z-axis motor, I had to get a bit creative because I'm using a Nema 24 motor, and it's a closed loop motor which is slightly longer than the original. I had to make my own plate for the motor and my own brackets. The reason why I'm using these motors instead of Nema 23s is because these can be a little bit shorter and still have enough strength compared to Nema 23s, which would be much longer if I use the closed loop one, so that's why I choose this one. But the important part was that it still fitted in here between the extrusion and the bracket, so it could actually still move the axis. So fitting this should not be a problem. At least I hope so. And with that, we're finished with, in my case, the y-axis of the machine. Everything runs smooth as butter, looks nice and proper, so now it's time to throw this off the table and turn our attention to the base of the machine, or in my case, the x-axis of the machine. So let's throw it off and start with something new. So now that it's time to start assembling the base of the machine, I'm doing it slightly differently. The manual suggests that you build the whole frame of the machine and then put on the linear rails, but it's gonna be way simpler if I put them on now. The only reason why I think they're doing it the other way is because you can easily slide off the rails, so that's what I'm doing it my way. The Frank Sinatra ways of doing things. So I'm going to put the linear rails on, dial them in perfectly so they're parallel to the profile, and then start assembling of the whole profile like the manual suggests. After a long session of assembling everything together and making sure that everything is nice and square, we finally arrive at the build base of the machine. You really have to make sure that all of these are 90 degrees, which they are after a bit of finicking, but they're nice and square. Another thing you have to make sure when you build this, your diagonals, they have to be spot on, maybe half a millimeter off on one side, so I'm not gonna complain about it too much. Measuring is made easier with this 3D print part, which makes measuring alone much simpler and much more constant than just finicking with the measuring tape. So now that this is done, we have to start mounting the motor mounts that I've made. So it's business as usual. So in the name of a smaller footprint of the machine, I had to get a bit of creative and make my own brackets for the motor mounts, because in the original the stepper drivers are direct drive, and that takes up more space since the motor gets to about back here, and therefore a larger footprint of the machine. So that's why I had to turn them all around, but it still should work the same way. So let's get to mounting of the brackets and possibly motors, and then ball screw. And now that the gantry of the machine has been added to the base, it's finally over. The spooky part is no more. Up next, adding the motor brackets. for the Y-axis and adding the stepper motor to it. After that, not much is left except a couple of sensors, cable chains and such little things, so let's finish this. I made myself these corner brackets for mounting the CNC to the table because sliding CNCs don't really sound that good, at least to me, but to each their own. Or you could use them for mounting the spoil board to the machine, because in the community I kinda saw people having issues with lifted spoil boards. So I'm trying to mitigate that with these brackets, which I will have 4 per square, so 16 in all. I have a nut inside the bracket so I can easily mount things from above. If friction isn't enough, there's a bolt right there that slightly protrudes over the nut so it doesn't fall off. So time for more assembly. So the spindle for the CNC just arrived. It's going to replace the dummy spindle in the carrier right now, but it's an automatic tool changing spindle. But for now I'm going to use it mainly for manual tool changes. So we're gonna open it together because look at the experience. It's like 200 bucks in hardware for the box alone, so let's see what we're dealing with. And hot diddly damn, if that's not a nice spindle. So this spindle's kind of special. It's an automatic tool changing spindle. That's not the special part. The special part is that it's 80 millimeters, which fits in the RatRig mounts, which is kind of good for me since I already have the spindle mounts and I don't want to get bigger spindle mounts because most of the automatic tool changing spindles come in 10 millimeters or up. It has a ISO 20 taper inside, so up to a ER20 collet, so that's what I was using before, so no big difference for me on that area. You get a solenoid valve with the spindle, which is kind of nice, but it would be a bit nicer if I knew beforehand before ordering my own. And just like that, the spindle is now mounted. It fits normal into the RatRig mounts for the spindle. Nothing too special down below. Currently I don't have a collet for the spindle, they're on their way, but I made a collet myself just to see what we're fighting for, and it's going to look absolutely adorable. This little spindle gets pulled up a bit more, but kind of get the general idea. I've talked to the manufacturer of this spindle, and this product is not fully fledged yet, still working on the manuals, on that shenanigans, but it's not too hard to connect everything. But basically for the dust remover and the air sealing to step down the pressure to 2 bars, and other than that, nothing difficult. If you're uncertain or short on time, you can still make it work just with air cylinder valves. Well, without further ado, other shenanigans. And the other shenanigans I'm up to is putting brushes over the linear rails, because we don't want debris getting on the linear rails because it's bad even though it has wipers on the end of the carriages. So we're gonna cover them just like this. I basically bought just a door brush that you usually see mounted underneath the door, so you get a slightly better seal, imaginary. Made myself some holders for the brush and I'm going to mount it just like that. So I made a couple of holes into the spoil board of the CNC, which are going to have tool holders for the tool holders, which is kind of an inception of itself. So with this, we're going to have at least 9 tools on the table on standby for a tool change that's going to look something like this. Imagine a tool holder here. Just like that, the tool has been changed without needing any tools like a wrench. That's for suckers. We do rapid change. So now I need to make more tool holders for the tool holders. So let's get to making some more tool holders. And now we can perform tool changes with just a press of a button right there. And just like that, we change our tool. Isn't this amazing? I'm just kind of blown away by, tool change. Might have to edit the code for the tool change, because for now I kind of wanted to go one axis at a time, but I'm not that proficient in writing code just yet. And now that we have all of the tool holders for the tool holders, we're actually ready to start making stuff. It's been a while since I recorded anything. So a couple of things I added is the splashboard, kind of a rough name, but the general idea is that when making stuff here, the chips might fall over the table and get into this little nook and cranny of the machine, which is hard to clean, like on the previous machine, so we improved that. We added some suction capabilities. This is not a permanent solution, a couple of things still need to be made, like a hose clamp, but the rest is kind of just a couple of holders. The pipe goes down under the table and comes out around here. Made an attachment for the vacuum, which is a similar attachment as here for the actual dust boot, which I designed myself because it has to be automatic tool changer friendly because of this side and next tool holder. So I had to design one myself. It has a removable magnetic brush, which I still have to make a couple of versions of, maybe a shorter one. I was thinking one with a transparent front for you, dear viewer. But also another thing I added is the ring light on the spindle, which will allow you to see all of the action that's going on underneath where the routing's going on. So another neat thing about this dust boot, alongside with being automatic tool change friendly, is that it has a removable hose, which will allow me to, after I'm done working, clean up the work area pretty easily. And then if you have two hands, you can attach it back on easily and proceed with the work. So this is going to do it for this epic CNC build video. There's still a couple of things I need to do, like tidying up the cables, putting this display for the frequency drive somewhere neat, adding maybe a couple of inputs for the electricity, tidying up the drawers because they're a mess right now, but don't worry about it. Also, a couple of the electrical things still need to be figured out, but all in all, it's a fun project. But a couple of things for maybe RatRig to address in maybe a future iteration is probably, first things first, the flexing of the spoil board is kind of a problem. Even though I pinned that down in 16 locations, I had to add these 2 more brackets on each side because kind of minimize the flexing in the corners. Another thing that would be kind of nice to see in the future iterations is some kind of plate here or some kind of a clamping mechanism for the C profile of the gantry, because it's easily flexible in this direction between the extrusions, There are just 6 things holding it together, 4 of these angled doodads in here, and the plate. It's enough, but I would like to see a bit more strength in the gantry. I might address that later. Also another thing, but that's kind of my problem, not the general project problem, is the use of these electromagnetic end stops, because the homing is not as consistent as I would like it to be. So the problem is I have tied the tool holders to the coordinates of the machine, which slightly change when I'm homing the machine. It's been mostly constant, it's not a problem, but when it doesn't home properly, it's a bit of trouble because it can break stuff. But that again is my problem, so I'm going to address it with some physical switches. But again, these are my specific problems for my specific use case, so keep that in mind. So I think the video is long enough, so I'm not gonna do any cut demonstrations because you're gonna see the use of this CNC in the future projects, but I expect carving of wood to be an easy task for the machine. Aluminum cutting, still an easy task, but steel, I might have to still kind of learn the settings because I already milled steel on this machine for the cover of the noise contained guitar. It was a bit of a challenge, but I'm still not used to the machine. It's way faster than the previous machine. So this is going to do it for this video. I know it's been a departure from what I usually do, but sometimes we have to spice things up with different projects. But thank you for joining me on this amazing build project. It's been fun. So without further ado, thank you for joining me, and goodbye.